Okay, close enough. All right, let's get this started. Welcome, everybody. So I'm Chris Holmes and Nadine. Do we hear you?
Yes. Good morning.
Good morning.
Sorry, I'm just like trying to keep up with the chat and people waving cute hands around.
Cool. So let's get this started. Thanks everybody for coming. Super excited to welcome you all and kick off this day. So little agenda for this next half hour, 45 minutes. We're going to give a quick overview of the event, thank the sponsors. Nadine's going to talk about OGC and Cloud Native Geo. Then I'm going to dive into the overview of Cloud Native Geo. Howard's going to help me out a bit with that too. And then from that, we'll go into the first session on Cloud Optimized Geotips from Jed. It'll be approximately 10:40, but I don't think we're trying to keep that time super exact and might be a little bit earlier for that. So I think we've got a really great event for all of you. The definitive place for the schedule is the schedule.cloudnativegeo.org. I don't anticipate it changing that much, but check there to make sure. We'll keep it up to date if anything moves and changes around. So the goal behind the organization is to really make this about outreach, this place where new people can learn about all that's going on in these cool communities, but should also be lots of fun for experts in the cloud native geospatial to learn how this tech's used and what people are doing with it. So if you're new to this world, I'd say the most important talks to attend are these overviews. I'll give this overall one on the ecosystem, and there are ones for COG, Stack, ZAR, and Copic. Well, you'll learn about each of them, get that bigger perspective. And then the lightning talks are going to give you a bunch of different perspectives, diving into various corners of this pretty vast ecosystem. And then we've got tutorials. So these are an hour-long opportunities to go deeper into a subject. 4 of these require kind of some software development background to get the most out of them, but everyone's welcome to come along. You can follow along, see what people are doing deep in the code, and you'll likely learn a decent bit, even if you don't code. And then we're a single track event, so there's just the main session, log on here. If we start from behind, just check the order online. The order is going to be the thing that puts us on track, but we've built in a lot of buffer time, so hopefully we won't get too far off track. Each hour of sessions aims to build in a little extra time for Q&A at the end of the hour. So save your questions for that. If talks take longer than expected, we'll probably cut the Q&A short to keep to our schedule. And then we've got this hour-long Q&A session designed for everyone to come ask all their questions. So you can hop onto that. And then the other main way to get your questions answered is this chat we've got going on Gitter. So Gitter's super easy to join. It's just a web link, works fully online. I think there's other ways to hook up clients to it, but you can sign in with Twitter or GitHub to actually chat. Links in this chat to get onto there and wave and say hey. I don't see it right now, but hopefully people are already talking. And all presenters will try to be on after their talk, so if you want to ask them questions, do for that, and encourage any and all conversations. So encourage to tweet out, use social media. I've got a hashtag you can use. I don't know, I'm the expert at hashtags, but this one seemed fine. Also note that a lot of the specs have their own handles, so if you're using them, tag those, and then you can get engagement there. So then before we have Nadine share about OGC, I want to introduce all our sponsors. It's been super cool to see all the support. They're Cardo, definitely one of my favorite companies. It's their first time supporting this space. Mostly because they play a lot more in the vector space, and a lot of this cloud native tech hasn't quite hit vector yet, but they're a long-time innovator in cloud technology, really SaaS from the beginning, and they're embracing cloud data warehouses like BigQuery and Snowflake. Everyone should tune into Javi De La Torre's talk about cloud native vector session. It's at the cloud native vector session tomorrow at 1500 UTC. He's taught me most of what I know about this area, and I'm super excited to have him share his knowledge with you all. It's been cool collaborating on GeoParquet with the Cardo team. So any other words, Nadine, or do you want to introduce Planet?
No, I think +1 on Javier and his team. Definitely very practical, very inspirational, and thank you for sponsoring, and thank you, Planet. So Planet is not a stranger to any of us. They've been longtime supporters of anything open. And we're not talking here about just the financial support. We're talking about time and dedication, everything that Chris has put in just to make this event happen. I think we all agree that we're all here because Chris brought the community together. Chris and Planet have been big supporters of the APIs, so it's great to see them committed to this transformation, this evolution of geospatial and geospatial standards, and taking the community with all of us, and now with cloud native geospatial, which is the next big thing. So I can only say thank you.
Yeah, and yeah, check out Sarah Safavi's talk. It's in about 3 hours. That'll go deeper into what the planet's up to in this domain and what we're doing next as well. And then Development C is coming with as our partner sponsor. They're one of my favorite organizations, doing a whole lot of innovative work for their clients and building up a really cool stack of open source tools in support of this. And yeah, see Ian Schuler give his perspective on cloud native geo in the session that Sarah's going to kick off. And then yeah, the other sponsors, Azavia, they're the ones behind GeoTrellis, do amazing work on GeoParquet. Check out Eugene's talk on spatial indices tomorrow. Radiant Earth was the nonprofit that started Stack. They ran this event last year, and they do a bunch of amazing work with machine learning for development. Up42 is a really cool platform for satellite data, creating developer accessible marketplaces, and they're really pushing Stack for the whole industry because they see this spot as a sort of reseller and platform where everyone gets better as we do that. You want to share NRCan and SAFE, Nadine?
Yes, I definitely want to, big shout out to Natural Resources Canada for also supporting and sponsoring this event. So NRCan, I call them the model strategic member of OGC. They have always been supporters of international collaboration, and standards come just under that international collaboration and that commitment to interoperability to solve these big problems. So happy that they're sponsoring this, and happy that they're also committing via this sponsoring this event to the next generation of geospatial standards. I can say the same with Amazon Web Services, AWS, another great principal member of OGC. Most recently, they actually sponsored our member meeting and provided 8 workshops on geospatial on the cloud for free for anybody, and these are also recorded and available. And Chris knows they provide tons of data in COG and Stack and their public data program, and I believe they have a few folks also talking this week about these capabilities.
Yep.
Yeah.
You're going to do SAFE.
Yeah. I definitely want to do SAFE software. For those of you who are not familiar with SAFE, you've probably heard of FME. So SAFE software is the company behind the FME software, and true believers of making geospatial information accessible and reusable. You'll be hearing a lot about that today. And again, thankful for their support for standards over the years. I think it makes their jobs easy, and it's great to have them as sponsors here as well.
Yeah, and then Cartoza is probably my favorite QGIS shop, or pretty easily my favorite QGIS shop, and one of my favorite companies in general. They built the QGIS Stack plugin, and you can learn more about that in a session tomorrow. So yeah, a bunch of really cutting edge companies, organizations. Yeah, thanks again. And yeah, if you want introductions to anybody at these great places, let me or Nadine know. And with that, I'll hand it over to Nadine.
Yeah, so I'll be quick, Chris. First of all, I really want to reiterate my personal thank you. You're the reason we're here today. I've seen how hard you've worked to make this event happen for the last month. So thank you for bringing the community together in the true, I think, true outreach fashion. We have, I think, more than 70 representatives from all over the world speaking. We had more than 1,300 people registered to attend, and I think this is just a proof, right, to one, the timeliness of the topic that we're covering, cloud native geo, and also proof of the interest of the community. And that's why I'm going to hit on community again, almost like the C in OGC is community, because that's how I see us. We are a global community of organizations. I have a sample here, government, industry, academia from all over the world. And I'm very proud and happy that we are at our largest ever as a consortium these days, because there's never been a better time to be in geospatial. And you think what we can do with cloud native geospatial is huge. So I look at us as a community of the geospatial experts, the users of geospatial, the innovators around geospatial, and our purpose becomes trying to help solve complex problems by making something that has geospatial in it, or location information, findable, accessible, interoperable, reusable. So lowering the barrier so that anybody can use this amazing thing we all know what to do with, which is geospatial and location. And on our way to solving these problems, we find these interoperability challenges, and we fill those gaps with standards. We document and share how we're using those standards and how we're solving these problems with the best practices. And I think most of all, we just help each other as a community. And we've been doing this for 27 years, which is great. So if we go to the next slide, and I did this last night because I really, really think this event is such a milestone for OGC, because I still remember 1999, I was a student at MIT, and I attended the event that brought the Web Map Service community at the time. And at the time, if you do one click, Chris, WMS, you can see this here, it puts a smile on my face, was called a breakthrough, revolutionize geospatial data on the web. We're going to increase the value of geographic data. And now, if you advance to the next slide and you look at us 27 years later, and there are 3.5 million unique WMSs out there in the world. And I can say we've come a long, long way, not just with the web services, so those were the WMS, WFS, WCS, WPS, but the next slide, most recently with the OGC APIs, which also Chris helped us with, which is another frontier by the community to be developer friendly to the non-geo geeks, right? We're really, really lowering the barrier so that any developer can do wonders with geospatial data, which we know can be done, right? So for me, it's like a flashback, this whole event, to 1999, as I felt as a young, excited student participating in an amazing event, in awe of everybody speaking and what we are trying to do together. And I feel the same today. We're kicking off this cloud native geospatial community outreach event. I think 20 years from now, we will all look back at this moment and reflect on how together we were really just making amazing stuff happen for everybody. So thank you, everybody on the line, everybody who's going to listen to this later, for being here, for sharing your expertise, for being open. We talk about open standards, but you're open people, for being here to learn. I think that's the 300 plus people to grow so that we can build the foundation for cloud native geospatial standards, the next glue. And together, I think we can build on the cloud. I'll say it again, lowering the barriers, the cost, the time for sharing, for using geospatial information when so much of it is on the cloud. And in the process, and I think if you listen carefully, the next 2 days, we're empowering innovation. We're driving the development of the next generation tools. And we're really, really making geospatial information, or more, broadly location information, fair. So the next slide, findable, accessible, interoperable, reusable, at scale, right, for massive, massive impact. I always finish my talks by saying, don't take my word for it. You have to listen directly, hear from the experts. So you have 2 full days, immerse yourselves in what the community is doing with cloud native geospatial and what OGC is doing to incorporate community standards into our standards portfolio. So I would encourage you, as a matter of fact, we have Scott Simmons, our Chief Standards Officer, will be sharing towards the end of the 2 days the latest and greatest on what we're doing to incorporate everything that you're going to see in these 2 days. And I am sure we will continue this exchange at the OGC member meeting the week of June 13 in Madrid. So save the date right now. And with that, I'll pass it back to you, Chris, and with another thank you.
Awesome. Cool. Thanks so much, Nadine. Great overview. So I'm excited to kick things off for the first sort of overview talk with this attempt to explain this cloud native geospatial idea. We've really had this goal to make this an outreach event where people can come and learn more about what's going on in this world. So yeah, I think we had over 1,300 people register. And so I'm sure many of you are new to this world. I wear a few different hats, Planet, OGC, Radiant Earth. Right now, Planet supports most of my time on this stuff, but for this talk, I'm really kind of speaking for the community, not representing any organization. So super rough overview of what we'll cover. I'll start explaining what Cloud Native Geo is. I'll hand it over to Howard, who leads the COPIC project, to explain kind of the underpinning philosophy, key technical aspects, and then I'll take over on what it enables and close out with an opportunity that I see for all of us. So this is likely the first question of anyone diving into this community. What is this stuff? This is a definition we've used, software, geospatial, built for the cloud from the ground up, but what does that actually mean? So geospatial software has this long history as a desktop tool with specially trained experts who do analysis, make maps on powerful workstations. And this worked quite well for a while. These big beefy machines could handle most all the data that one would need for any common task. But we've had this explosion of data in the last few years. Satellite imagery certainly, but also all kinds of vector data as well. Every cell phone location is a point stored somewhere, credit card transactions. So even the beefiest desktop machines with huge hard drives can't keep up with how much relevant data there is for a kind of deep analysis. Thankfully, the last few years have also seen this mega trend with the rise of cloud computing. So cloud offers near infinite compute and storage. So what we're doing with Cloud Native Geospatial is throwing out those constraints that the whole geospatial industry was built on. We start with this notion that all the world's data should be readily available on the cloud, where there's that computational power to process it all at once. And from there, we're rebuilding how analysis and map making is done, creating new ways of working. So the first real world example of the power of Cloud Native Geospatial was a tool built by Google called Earth Engine. With it, you can access data instantly on the cloud. You can run computations on thousands of machines at once, create cool time lapses like these, but also a whole lot more. And there's over 50 petabytes of data in their catalog, enabling visualization of deforestation over large timescales and regions. But the most important thing is it enables global scale analysis. So this map from Global Forest Watch shows forest loss. And it was one of the first compute projects that did analysis of the entire globe from a deep time series of data. This type of analysis just wasn't possible before. And this would have taken 15 years to perform on a single computer, but it was completed in just a few days using Earth Engine in 2012. And the cool thing is today, back then it took a bunch of people kind of hand-holding it to make it work. Right now, anybody can sign up for Earth Engine and see deep time series analysis results in local areas in seconds. It just processes it on the fly. Then when you're happy with the performance of your algorithm, you can run your own global scale analysis in days. So anyone now has access to computing power for global scale analysis. So Google Earth Engine sounds cool. What's this have to do with all these standards you keep hearing about? What we're doing today is working on the formats that let anyone publish data in a cloud optimized format and instantly enable a complete ecosystem of tools. So this means any scalable compute solution can access the same data and run any type of analysis, from traditional remote sensing, geospatial processing, all the way to artificial intelligence and machine learning techniques. And they don't need to download the data and maintain their own copy. We can finally bring these questions to the data. So our vision is that all the data in the world should be available in open formats on the cloud to be used not only in Google Earth Engine, but any other tool. And like Nadine said, this data needs to be findable, accessible, and interoperable. So we see this vast ecosystem of tools built on this foundation. And I really see this like the World Wide Web, where there's layer and layer of innovation. You know, the World Wide Web is this simple HTML format on top of which so much is built. And I kind of see these specs as that hopefully similar foundation where we see layers and layers of innovation. So you're going to hear a lot more about the standards in the overview talks and in many talks throughout the next 2 days. But to give a super quick demo of what's possible, I'll use Copic, which is the newest cloud native format. As you can see, the Copic data is stored online. It's just this URL. And you can just point a viewer at the URL and you instantly get a fully capable visualization engine. There's no server running. The format itself is optimized so a browser can read it directly and stream just what it needs. And this is really the standard pattern. Data can live directly online and various tools can stream just the bits they need. It makes kind of smart use of how HTTP works, organizing the file format so it can be streamed like a movie. The quick overview of the specs: Copic enables point clouds like you just saw. COG, cloud optimized geotiffs, is for multispectral data like satellite imagery and is really the one that started this all. ZAR is great for multidimensional data, think climate and weather data, hyperspectral captures, dense time series, and then Stacks, this cloud-friendly metadata format that makes it easy to find the other three. Astute observers will notice I didn't have a cloud version for kind of point line polygon data like a shapefile or a GeoJSON. I think there's potential for format here, but we've got a lot more experimentation to do. This is going to be a hot topic at this event. There's going to be a cloud native vector session, and also check out Bjorn's talk on flat GeoBuff, which is a leading format possibility. So now I'd like to turn over to Howard Butler, who leads the Copic project, to kind of explain the uniting philosophy behind these formats and some of the technical underpinnings that enable this.
Thanks, Chris. Yeah, so I sent a note to Chris when I was working on my slide deck and asked, you know, kind of what are the technical principles of cloud native geospatial? Like, what are the major keystone or points? And you know, one kind of uniting principle of the data, yeah, next slide, is you know, we use the, you know, you look for adjectives massive, right, or data with mass, and trying to support or allow that data to have velocity, right? You want to be able to compute it quickly, you want to be able to extract what you need, you want to be able to visualize it. And so the kind of three main tasks that that cloud native geospatial are trying to tackle is support for automation, right? So that applications can quickly and conveniently attack and work through the data that they want and need. Discovery and having kind of a roadmap to get through content, and then federation to be able to take multiple pieces of content together and put them together into applications to answer specific questions. Next slide. So given those challenges, what are some of the principles of how these formats, how these protocols are being developed? So the first one, of course, I think emerging is something read-oriented, right? That doesn't mean write-only, or excuse me, read-only, but it certainly means read-oriented. In some sort of index-accelerated access, and almost exclusively over HTTP, at least as a baseline technical protocol. Open specification software and data, and then something I call multi-scale metadata. Next slide, please. And so for read orientation, it's access over the network is a primary use or a primary desire, but also the ability for applications to touch that data in parallel and touch that data partially, right? So an application controls access through the content, and it needs to be able to do that in ways that it knows how it needs to do it. Convenience and compatibility are also kind of guiding principles in terms of what are the formats, how do they move up and down the stack. You see that with cloud optimized GeoTIFF, certainly you see that with cloud optimized point cloud as well, right? So there's kind of a built-in compatibility there with what's gone on in the past. And then kind of assumed, but maybe needed to be stated, there's always a compression story here of some kind. Compression is always kind of content specific and application specific, but it's always there. Partial access, HTTP 206 for any of the web developers here. That was kind of an enabling protocol use that was guiding what was going on. S3, Google Cloud Storage, and Azure Blob all have HTTP interfaces. You can access content partially over, touch a large file and only ask for the bytes that you might need. And this allows applications to control how they traverse through the content. And to be able to do that, they need some sort of indexing mechanism, but they also need to be able to do that in parallel and be able to control how much content is coming at them. And next slide, please, Chris. Another guiding technical principle is openness. And we have these open specifications like Cloud Optimized GeoTIFF, ZAR, Cloud Optimized Point Cloud. They're kind of the collaboration space for how these communities interact with each other. But it's also based on open source software that is being used to extract value from the content, answer questions, process data, and then finally open data, large collections of open data supported by the commercial clouds themselves that provide network effect for people to compute and extract and work on this content with the open source software and open specifications. And the final kind of piece I would posit is this concept of what I call multi-scale metadata. And so you'll hear a lot during the talks here the next couple of days about Stack. And the three principal objects in Stack are item, collection, and catalog. And what these allow a user to do is to provide a map through the content, right? And this indirection allows applications to move through the content and access and manage what they select what they need and process what they need. And the Stack catalog or Stack map is consumption-oriented information. It's not what I would call origination-oriented, meaning it's not how those pixels came into being or how this point cloud came into being. It's what information do I need as an application to be able to traverse, select, filter, and process that content. And so these were kind of some of the principles I had come up with, at least and currently in 2022 as technical principles of where we're seeing cloud native geospatial be active in the commercial and open source space. And so I'll hand it back to Chris.
Awesome. Thanks so much, Howard. That was great. So I want to spend a bit of time on what this whole philosophy actually enables, what you kind of get when you embrace it. So I think the core is this radical simplification of the effort needed to make geospatial data findable, accessible, interoperable. I wrote a blog post called Cloud Native OGC that talked about this, so you can read that for a little more details, but I want to reiterate its main point. For many years, countries have been embarking on these huge projects to create spatial data infrastructure. Many made really great progress at the country level. You can find a whole lot of data online, and then sort of well-resourced subnational entities like big states with lots of money in the US. But I think where we've fallen short is the long tail. Inspire, the pan-European SDN initiative, originally imagined that every local municipality would make their geospatial data available through their own servers to support environmental policies. Most national level entities have done this, but few local level entities have followed suit. And I believe the reason is that they're not sharing it is because it's a big burden to make geospatial data available in the current architecture. Any data provider is going to need servers, either on-premise or on the cloud, a spatial database, geospatial application server software, and specialized IT staff, beyond just the GIS specialists who create the data. It's a different skill set to maintain these, and it's just a significant investment. And that's just for data that isn't even that popular. If your data is going to be well used, it takes an even bigger infrastructure investment. High availability databases running on multiple servers, load balance applications, 24/7 staffing on pager duty to bring it back up if something goes wrong. I was involved in the launch of this FCC broadband map several years ago, and it was just a lot of people working on this to make sure this would stay up. And then the local government doesn't even know if their data might get popular, so any major attention online could just bring their servers down. What cloud native Geo posits is that publishing data to share online should be as simple as dragging a file onto cloud storage, and if it's publicly available, anyone can instantly access it. This shows how you can publish data, and it can go into a Copic view. I just take my file, drag it in my cloud storage, upload, drop that public URL in, and it's there. And if I put a simple stack JSON next to it, then it's available for search and additional tools. And the key is this provider of the data no longer has to deal with scaling to meet demand. All of that's handled by cloud providers who have really made it their business to handle infinite scalability challenges for everybody. So this cloud native Geo architecture relies on their cloud storage offerings, which are one of the most reliable and scalable pieces of their infrastructure. But doesn't it cost money to scale? You know, if this data set becomes really popular, is those costs on this cloud storage going to creep up? And that's possible. That's what's called egress. There's a charge for data moving over the network. But if the data provider really doesn't have money to cover even the potential egress charges, they can make use of this feature called requester pays that's offered by the clouds. And you can see I can take that same Copic file that I just uploaded, turn on requester pays, and with that, it's the user of the data who pays for it. For most users, that's a pretty trivial cost. You know, once you're online, especially to stream it, it's pennies, even less. But if someone wants to scrape a huge amount of data, just rifle through your whole thing and download it, then it puts it on the bill on them. The data provider doesn't have to have the bill. The data provider just pays for the storage, and that storage is super cheap, you know, for even pretty massive amounts of data. But there's going to be no huge bill if the data gets popular. So most creators of valuable geospatial information are also not also experts in standing up software to make it available. So I believe cloud native geospatial changes the dynamic, so it's much easier and cheaper to publish data and make it useful. And the core idea is once data is published, it becomes instantly accessible in an array of compelling tools and much easier to find with stack metadata. So this little demo shows QGIS to search stack catalogs directly for data of relevance to an area, in this case using Planetary Computer from Microsoft. You can find cogs, bring them directly into your environment. So we've got almost all the pieces, so a publisher can put data online and enable people to find it and use it in context. I think we as a community have a lot more work to do to make this a really compelling, seamless value proposition, but you kind of see the pieces in place where, hey, I can just get it, search it, use it. And I think in the next few days, you're going to see a lot of really interesting progress and success stories. So yeah, definitely check out the other talks of what everybody's doing to make this stuff happen. So I'd like to close this talk with a few thoughts on what I see as the opportunity we have as a community. We all know geospatial data has the potential to have a huge impact on the world. And our opportunity is to make that happen, to really enable geospatial data analysis to be a part of everyone's life. You know, geospatial does have a big impact today, but it's on a pretty narrow set of vertical industries. You know, it's focused on the ones where the value of geospatial insight is obvious, and they've built up these teams of specialists and, you know, people who do geospatial. But it has the potential to touch every aspect of our lives, to show its value in domains where organizations don't have a GS department. COVID started to show potential of geospatial data analysis for healthcare, and that's not a vertical where we've really had that much traction. The mortgage crisis of 2008 was really spatial in nature. These were maps that were used in the official government assessment of what happened. But you can imagine like real-time mortgage trackers helping provide much more awareness for what's happening and potentially even preventing the next crisis. And then what I believe is really the biggest opportunity of all for us to enable the sustainability transformation. We think a lot about this at Planet. You know, how do we enable society to value natural systems in the economy by measuring exactly what is happening on the earth? Things like company ESG ratings, bank green bond verification, government regulation enforcement should all be spatially informed. And geospatial data should really be at the center of all decision making about our planet. But everyone who works in with spatial data sees its power to help inform decisions and change the world. But even though the world's getting more data driven, I think most of these decisions just aren't made with spatial data. And it can be frustrating to feel like, we have all this relevant insight, but no one really seems interested. So I want to talk about our opportunity. And I have to acknowledge, I don't think there's anything that makes cloud native geospatial inherently more likely to be used in kind of real decision making and get into real everybody's life. Having the data all online and easily streamable definitely makes it possible to be more accessible, but we could easily just create a whole new set of tools that are just as hard to use by non-geo experts. And we're probably cursed to do so if we just focus on the problems as we see them instead of really understanding why geospatial data isn't used more. So I believe we have an opportunity at kind of this critical moment where much of this cloud native geotechnology is just starting to go mainstream. And that opportunity is really to meet people more than halfway. Too often we expect people should take the time to understand what we do. But I think it's possible to build libraries, formats, standards, tools that don't force users to understand our complicated world. We need to view it as our responsibility to make things simple, to abstract out the hard stuff and give people a shallow learning curve. Let them do great things, even if they don't bother to learn all about projections, spatial databases, conflation, spectral bands. And to do this, I think we really need to put ourselves in the shoes of our users. Try out all the experience of someone completely new using a data set we're distributing, a tool we've released, an analysis we've made. And I think our goal is actually to let people be very lazy. We have to assume that no one has the time to learn what we have. They just want to realize that immediate value. So that may feel pretty abstract. So I want to give a concrete example of some new geospatial software that's really taking this responsibility quite seriously. Last week, I was interested in Spatial Finance's 2 geo-asset databases. These are really cool data sets to enable this kind of spatial finance for sustainability accounting. And I was a little disappointed they were in Excel because as a geo person, it's not the best format, but I pulled them down. But I was able to just drag them into Placemark, select the right sheet, and it all just worked. I didn't have to select lat long fields, it got it right. No file format conversion, I wasn't having to figure out Excel and put it into something else. It just worked. And I think we all just need to take this level of care for our users. And I know Tom spent a lot of time getting this drag and drop right. And it can feel not really worth the effort, but it's exactly this type of investment that gives the type of experience that welcomes people to the geospatial world. We, in turn, this cloud native community, actually need to enable Tom to be super lazy. He wanted to make use of cogs and was trying to figure out what he would need in order to add it to Placemark. But using them on the web isn't actually guaranteed to just work. I think Greg of Synergize is going to dive into this a bit more in his talk. But Tom's focused on real-time collaboration on vector data in Placemark. So adding cog support just isn't key for him. But if he knew that any cog he pointed out would for sure work, and there's well-tested libraries to do it for him, he'd throw it in. And for every Tom who does deeply know geospatial and has the network to ask, there's kind of hundreds of developers who would use geospatial but don't even know to ask the question. So I think at the base level, we need to design our standards and then experience of using them to be simple and accessible, invest to make the tools around them really just work. I do think cloud native geo is doing better than a lot of the geospatial world in this regard, but I think we're at this key junction where we've established this technological base that has the potential for layers of innovation on it. And I think the question is, do we prioritize the use cases within our community, or do we prioritize making it all easy to use for others? And to me, to make that impact we dream of, I think we prioritize making it use. I think there's a lot of ways everyone can help. I don't think I'll go through them now to give Jed good time to talk, but I'll drop some of these ideas on Gitter and share your other ideas of how everyone can help make things more accessible. I do think one of the key ones is making lots of data available in these formats, and the next frontier for us is really search. This is a really contrived example that I'm showing, but it shows a successful search you can do today on Google, where you can put it in Google, see data in full resolution, stream the entire asset in 10 of these other tools. And I think the more interesting and valuable data there is online, the more people will build tools and search engines to find and make use of that data. So I want to just close by saying thank you. Thank you for showing up to learn more about all that's going on in this movement. Thanks to everyone building tools and sharing data in these formats. And yeah, thanks especially to our speakers for taking the time to share what you're up to. Back to my how you can help. So yeah, I think you can help test experience of creating, distributing, and using cloud native geo. So if you are trying out to share on this, make your feedback known to all the developers. Help test experience with new users. So find new users who might want to use this stuff and see how it works for them and give that feedback. And then yeah, really create tools that make things easier to use. Prioritizing simple pieces that are loosely coupled instead of like one big tool to rule them all. And then yeah, like we all need to do all that we can to get as much data as possible in these formats so that value is really there and available.